Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about pouring one out for the great planet hunter in the sky, and if I have time, giant exploding stars of doom, and also science, and of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern. You can call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about making a hypothesis. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSIGN. For the next half hour, your agent of the stars. Got an exciting show for you today on Space Radio where we talk about all the beautiful things in this beautiful universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. You can call 888-581-0708 live or anytime and leave a voicemail. Get those calls in. You also follow along with the Space Cadets on the YouTube and Twitch live streams, tuning in live from around the world, including but not limited to Ashburton, New Zealand, Salt Lake City, Sofia, Bulgaria, the solar system, Odds, Hungary, Allentown, PA, Norway, and London, and Austin. I'm seeing them getting in right now as I begin those cities in so I can announce them on the air. That is, go to spaceradioshow.com for the links on how to join these live streams. We'll take questions that you send there too. Seriously, folks, I've only prepped 10 minutes of show material at the most, so get those calls in. Oakland, California, Edinburgh, UK. Oh man, you guys got in just 20 seconds too late. How you doing, Space Cadets? Good to see you. Glad for all the questions. New York City represent Siren Modern Dance. I know you. I know Siren Modern Dance. Siren, where's your next showing? Is it December 1st? Is it you and me December 1st? If not, put something else on the live stream so people, if they want to see you guys dance. Siren Modern Dance, for the Space Cadets, by the way, Siren Modern Dance, that's who was here last week. In studio, we had the performance, they were in residency, the workshop, the whole deal. That was last week's show, talking all about science and dance, exploring the nature of time. That's them. So yeah, if any Space Cadets want to be on the show and want to be interviewed, just fly yourself to Columbus and show up here Thursdays at 4 p.m. That's WCBE Radio Columbus, and you'll get on the show. Nice. Thank you, Nancy, for the Siren Nightbot command. All right, I'm going to do a little news. You guys know I got to talk about Kepler. Ooh, a good question, Raj. Write in if you guys have questions about Kepler, and I'll get to your question, Raj. Can we retrieve it? Before I start taking calls, I wanted to share some interesting bits of news that I caught recently. And, there better be taps in the background of this, Greg, in the show airing, because the Kepler space mission is done. A moment of silence, please. Thank you. The Kepler Space Telescope has been running for a decade, which is way longer than the original mission plan. And it is still haven't gotten used to it, was a planet hunter extraordinaire. It found thousands of planets orbiting other stars, most of which, about half of which, have been confirmed. So it gets a detection, it gets a signal, then passes that information along to ground-based telescopes and observatories for additional follow-up and more observation and confirmation. So even though the mission is done because it ran out of fuel, so it can't keep its station, it can't keep pointing in one spot on the sky for a very long time anymore, which is kind of essential for astronomy. And it also can't rotate itself, so it points its communication antenna back to Earth and transmit all the data and then go off back hunting. Can't do any of that anymore, so NASA called it quits. I called it a few months ago. NASA said it was running low on fuel. So we knew it was in hospice care. It was just, we're just trying to make the spacecraft comfortable, in its final months, so it could go to sleep peacefully. And it has, and now the end is here. And it's time to, one, reflect on the legacy of this amazing, amazing instrument and how wildly successful it was. And also look to the future, that its successor, the TESS instrument, is already up, already collecting data, already has some hints of some possible planets around other stars. So its successor is already up. Like, this is perfectly transitioned where we're end-of-lifing one instrument and ramping up its successor to keep searching for planets outside the solar system. Really looking for Earth 2.0 here. That's the end game. That is the end game. Or that's the end of the first game, and then it goes right into a new game after that. If you find an Earth 2.0, you're going to be asking if there's life 2.0. But goal number one is Earth 2.0. We haven't found Earth 2.0, but Kepler has definitely given us a tremendously complete and robust picture of what kind of planets orbit, what kind of stars, what are their demographics, what are the chances of finding an Earth-like star. And the space cadets are asking about Kepler right now. Raj Luthra is asking, is it possible to retrieve the Kepler Space Telescope? Well, here's the thing. The Kepler Space Telescope is not in orbit around the Earth. It is in orbit around the sun. It is millions of miles away from us. We are never getting that hunk of spacecraft back. And in fact, there might be some data stored on it that will never be transmitted to Earth, and so we'll never know what secrets it may have uncovered. But there will be decades more of analysis to come, because not all the data has been processed. We haven't gone through, we haven't done double checks, we haven't found confirmations. So there's plenty of work to do from this instrument. Even though it's done, its data lives on. What a wonderful legacy. That's the latest and greatest when it comes to space. It's time to have a conversation. So what do you think, Space Cadets? Was the Kepler your favorite space telescope? Like, I know it doesn't get as much press as Hubble, but of all the space-based instruments, is Kepler your favorite? Oh, great question. Great question, Chilpek Do on YouTube. Does Kepler even have fuel? Yes, it had fuel. It had fuel because it needed to twist and turn its body, and it needed power to run its reaction wheel so it can stay oriented, and that required fuel. And so the big problem with the spacecraft now is it can hang out here, but then it'll start drifting just because of random physics, and it needs to repoint, and it needs reaction mass, it needs exhaust, and it ran out of that stuff. And then if it wants to turn around to point its communication antenna back on Earth, it has to do this. That requires fuel. So yes, it did carry fuel. And Dawn is running low on fuel? I didn't know that. That just makes me sad. That just makes me sad. Pavel, I love your question. We've got voicemail, so I'm going to play the voicemail. And then if I have time after that, in this segment, I'll do one of these Space Cadet questions. You can't just say, Raj, you can't just say you like all the space telescopes. You have to pick one. There can only be one. I know my favorite. 10 points, 10 bonus points to the person who guesses my favorite space instrument. Take it away. You guys think about that. You Space Cadets think about it while I record the next segment. What do you think my favorite one is? Greg, do you know? Greg's got no idea. Greg doesn't even know what I'm talking about, which is usual. We've got a voicemail lined up here on Space Radio, so I'm going to play it. Greg, go for it.
Hi, Paul. This is Alex from Allentown, PA. I called Ask the Spaceman yesterday, and we were talking about strange lights. And ever since I heard of Cherenkov radiation, I just thought it was the coolest thing. And when I saw pictures of it, it made me wonder. I love the blue glow of it, but is that because of the medium that the charged particle is going through? Or would it be a different color in a different medium like glass or air? And what about the charged particle? Does that make a difference in the light? And lastly, what would a spectroscopy of that light show? Would it be the medium or something else? Thanks, Paul.
Really, really fun question. Thank you so much for that. And so he's referencing a podcast episode I did, the Ask a Spaceman podcast, where I did all the strange lights in the universe. And I went through a few examples of synchrotron emission, black body emission, and something called Cherenkov emission. Cherenkov emission is caused when a charged particle blasts through a medium like air or water, and where it goes faster than the speed of light in that material. It's never going to go faster than the speed of light in vacuum. That's kind of a rule of the universe, but it can beat light in a medium. So light goes through water or air slightly slower, and you can shove particles fast enough and it will beat light. And what this radiation is, it's a fun way to think about this, is it's like a bow shock, like a sonic boom, but for light, a light boom. And the question is about the color. There's this characteristic ghostly bluish whitish color that comes off of Cherenkov radiation. By the way, we see this in space like everywhere, and we also see it near nuclear reactors. So if you put a bunch of water around a nuclear reactor, there's charged particles streaming out of there faster than the speed of light in the water, and so you get this lovely, lovely blue light. I mean, it's cool light. Don't go anywhere near it. If you see Cherenkov radiation, you are probably going to die. So I advise you to back off. But the color comes from the energy. You are accelerating particles to extreme velocities, faster than the speed of light in that medium. And that's very energetic. So it's going to give off high energy radiation. It's going to give off blue light, ultraviolet, X-rays, maybe even gamma rays. So you're never really going to see, I suppose I shouldn't say never. You're rarely going to see low energy low energy Cherenkov radiation, because you need high energy situations to even cross the threshold of making a light boom and creating this kind of radiation. So depending on the charge of the particle, the mass of the particle, the thickness, the goopiness of the medium that it's traveling through, that will change the details of this Cherenkov radiation. You might be a little bit bluer, you might be more ultraviolet, you might even be X-ray if you're hard enough, but overall, it's going to be on that high energy end of the spectrum. Great question. Thank you so much for the voicemail. And remember, you can call 888-581-0708 anytime and leave a voicemail to get your question on the show. And coming from the Space Cadets, I got another question here. Oh, it was right here. Oh, I lost it. I'm going to pause. Sorry, Greg, because I had it. Oh, I'll answer... Great question from SAHM. So I'll answer this question from the Space Cadets SAHM, asking about, again, this orientation of Kepler. Like, there's been a lot of angst in the chat about why does a spacecraft that is just sitting in one spot need any fuel? Because you can do this thing called reaction wheels, where you just collect energy using something like a solar panel, store it in something like a battery, and then you have flywheels attached to the spacecraft that you can spin up or spin down, and through conservation of angular momentum, you can turn the body of the spacecraft. Just like if you're on, say, a wheelie office chair, you can twist one way and you'll start twisting, you can throw your body another way and you'll twist the other direction. It's like that, but in space and with a lot more engineering behind it. The Kepler spacecraft did have fuel. The reaction wheels that it did have were used for station keeping, for fine-tuned pointing, but it still needed to maneuver around, like I'm going to stare at this chunk of space, and then I'm going to point at this chunk of space over here, and that requires more than reaction wheels can provide. It needed fuel. It needed to squirt fuel out of the sides, a little bit of propellant, so it can twist and turn in space. And that's what it ran out of. And so it can't do that anymore. It can't do the job it needs to do as a telescope. There is an interesting little backstory for Kepler that I'll get into in the next segment about how it almost ended 5 years ago, but it kept going. And so I'll continue in a little bit. This is Space Radio. This show is brought to you by you. Go to patreon.com/pmsutter. Yes, I'm talking to you. Go there now to learn how you can support the show. By the way, I saw it. Someone guessed my favorite telescope, space telescope. Who was it? It was Root. Root, you are the winner. It's the Planck satellite. The Planck satellite is my favorite. Why? Because I was a member of the Planck collaboration. I worked on the data from that telescope. So of course it's my favorite. It paid my bills for a couple years. Oh, everything to the little Planck. Yes, Root, Kepler will be left to roam our solar system. Just hanging out. Just another piece of space junk. Okay, there were some questions at the beginning. Good. Okay, Carol, great question. You can do a couple questions in this segment. I'll do Carol. Sorry, Greg, I keep moving away from the microphone. I keep coming over here. Where's my questions for? Thank you so much, Nancy, for organizing all the questions, by the way. And I know even this show is not enough to answer all your questions, so don't worry. There's more projects coming. There's a tease there. There's a tease. Yeah, does time really exist? Ask Siren Modern Dance. All right. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more Space Cadet questions ready to go. But remember, you can join the conversation by calling 888-581-0708 anytime. You can leave a voicemail or call in live. We record every Thursday at 4 p.m. Eastern. Go to spaceradioshow.com for all the info and the links. Got a Space Cadet question here, turning away from Kepler because Kepler can't turn itself. Get it? It's out of fuel. That's the joke. Anyway, some Emre on YouTube, one of the Space Cadets, asks, I've never understood how the expansion of the universe takes place. Does the space between two objects stretch, or is more space being added out of nothing, causing two objects to drift apart? And I think this question, so I actually get this question a lot. I may or may not address the question in my new book, Your Place in the Universe, Understanding Our Big Messy Existence, coming out bookstores nationwide, November 20th. Sorry, I couldn't resist plugging the book. So the question is, like, does space, when we say the universe is expanding, is the space between two galaxies stretching out, or is more space being added? And I think this question comes from the use of analogies that we use to tackle this problem, to address this problem, to talk about this problem, where we imagine space-time as a giant rubber sheet, and it can be stretch and bend and fold and do all sorts of cool stuff. Or we imagine the expansion of the universe as if it were an expanding balloon, or a piece of bread baking in the oven. We think of this expansion, material expansion. I'm going to tell you here, the question of, is space being stretched out or is more space being added? It doesn't matter. It doesn't matter, because both of those terms, both of those words are themselves analogies. In the mathematics, and in physics is a mathematical description of the universe, so I have to go back to the mathematics. In the mathematics that describes the expansion of the universe, you have something called the metric. The metric is just the ruler of the universe. Not ruler as in emperor, ruler as in measuring tape. It's the measuring tape of the universe. It marks the distances between any set of points. So if I have two galaxies, I have a metric. It gives me a distance between those two galaxies. And in general relativity, our mathematical description for gravity, for the expansion of the universe, when we say two galaxies get further apart in time, all that means is that the metric, the set of rulers we use to measure distances, get bigger. That you'll look one day and the galaxies will be a certain distance apart, and you'll turn around and get preoccupied, and then the next day you go check, those galaxies will be further apart. That's all it says. That's it. That's it. Things like words like stretching or creation or addition, these are extra verbiage added on, like window dressing or salad dressing or any other kind of dressing you prefer on top of the mathematics so that we can communicate it without actually having to write down mathematical equations all the time. So when you're puzzled by this, and I totally get it, I totally get how you can be puzzled by this. Like, is space being stretched, or is space being created between two galaxies? It's neither. It's neither. It's the distance between two galaxies changes with time. That is it. That is it. Just retreat back. Whenever analogies become confusing, whenever metaphors lead to more questions than answers, then it's time to abandon the metaphors, abandon the analogies, retreat back to the mathematics, because the mathematics are crystal clear. And the mathematics just say the distance between two galaxies will increase with time. And that's it. So try not to worry about it. Try not to have too much angst over it, because this is just the way the universe works. That's cool. Now, I have another question here lined up back from the Space Cadets. Pausing again, Greg. There have been so many questions today. This is ridiculous. Where was it? This was the great question about the Higgs boson. Oh, I cannot find it. You guys are too dang curious. What is wrong with you people? How dare you be so curious and have such a thirst for knowledge? It was the question from Carol about the Higgs boson. And Nancy, you've done an amazing job putting it up here for me, pulling those questions out, but I just cannot find it. Do you see it, Nancy? How you guys doing, Space Cadets? It's going to take us 5 hours to record this show, because there's the question in there. How about I just call you Carol and we'll talk about the Higgs boson? I could have just faked it. Now I see it. Now I see it. I've got a question from Carol Sharp, one of the Space Cadets on YouTube, saying, hello, everybody. Hello, Carol. I know you will have a good show. Thank you very much. She's asking, what's going on with the Higgs boson? Is it safe or not? She loves the emails, loves the show. Thank you so much, Carol. Love your support. Now, the Higgs boson. Now, what's going on with that? The Higgs boson is a particle. Don't get too hung up on the name. Higgs is a guy, Peter Higgs, named after Peter. Could have just called it the Peter boson. That sounds legit, right? Boson is a kind of particle, so don't worry about too much. It's just a name. It's just a name for a particle that we know exists, was hypothesized to exist for decades, finally discovered about 10, 13 years ago, if I remember right, at the Large Hadron Collider. Finally found evidence for this particle, and it plays a very, very important role in our universe. It provides for mass in a exceedingly complicated way, and not all kinds of mass, just things like electrons, maybe neutrinos. Through interactions with the Higgs boson, they get mass. I am not going into that story right now. Just know that the Higgs boson plays a very, very important role. And it also plays a potentially very important role in the future of our universe. Because what we found something interesting in high energy physics. When you go to higher and higher energies, as you start smashing rocks together at higher and higher energies, the physics of the universe changes. At high energies, you don't have 4 forces of nature anymore. You only have 3. or maybe 2. And at extremely high energies, maybe even 1. Our universe is a low energy fractured state of a higher energy, more, I hesitate to use this word, but I'm going to go for it, pure state. A more symmetric state that as the universe cooled and aged, it fractured apart, gave rise to the 4 forces of nature and the particles and fields that we call our own. And it's been in this state for like 13.8 billion years. So maybe that's the ground state of the universe. This is the final state, but maybe not. Maybe it's got another bit to go. Maybe this isn't the final form of the universe, and it's governed of whether this is the final form of the universe, whether our universe will remain stable forever or eventually fall into a lower energy state is governed by the mass of the Higgs boson. If the mass of the Higgs boson is above a certain threshold, then our universe is unstable and will eventually decay, where there's brand new forces, brand new physics, and we're all dead. Sorry about that. And if it's below a certain threshold, then don't worry, it's all chill. We'll be obliterated by some other process, I'm sure, but not through a phase transition in the late universe. The current measured value of the Higgs boson puts it right on the line. So thank you, nature, for adding stress to our lives. That's the last thing we need, is fretting over a complete existential, and I mean the absolute epitome of the word existential crisis into our lives. Thanks, nature. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. I did see a question as I was scrolling through here about Kate and Lynn, Siren Modern Dance, whether they have formal STEM education. So they're dancers. They're dancers. They're choreographers. They're dancers. They run a company. That's the power of collaboration. That's the power of collaboration, because nobody wants to see me dance. And I'm guessing, no offense, Kate, that nobody wants to see you talk about physics. So that's why we collaborate, because then we can combine our powers and make a Voltron of understanding. There it is. What's outside the bread? There is no outside the bread, Mr. E Dude. The metaphor is leading you astray. What is my blue shift? I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I just want to say thank you for all the listeners who came out to the performance of TikTok last Saturday night with Siren Modern Dance, exploring the nature of time through movement and through science, through narration, through music, through dance. It was a wonderful evening where we got to open up this collaborative process, show you how a collaboration between a scientist and a choreographer and a dance company actually works and actually produces results. It was a totally magical evening. I had an amazing time. And that's not the only science and art thing I do. I was also very, very lucky to serve as a juror for an art exhibition hosted by the Columbus Cultural Arts Center called Hypotheses, art inspired by the many worlds of science. And I served with Professor Amy Youngs, an art professor at the Ohio State University. And we picked the art. There were hundreds of submissions. We picked, I think, 50 to go in the exhibition. And the artwork is absolutely stunning. There'll be a link on the website. It's still an exhibition now if you're living in Columbus. It's free. Just show up. It's there. And if you're not in Columbus, then go online. Go to spaceradioshow.com for a link to the Columbus Cultural Arts Center. They have some samples from the work on their website from the exhibition. And just absolutely mind-blowing stuff. I mean, stuff that ways of approaching the world, ways of approaching science, ways of communicating science, ways of approaching how we understand the world through science in a ways that I would have never imagined. Absolute, pure, unadulterated creativity and artistic expression that connected to me as a scientist and science communicator. I hope it connects to you. I had a lot of fun serving on the jury for that. The best jury I've ever served on, I will say that. And I want to close the show. I meant to do a joke when I was talking about Kepler. I know I did a couple jokes, but I have to give it to Campbell Duncan from New Zealand, who said 5 years ago, Kepler, the Kepler Space Telescope, suffered two gammy knees. Two of its reaction wheels failed, absolutely failed, and it should have ended the mission right there, but instead the engineers were able to orient the spacecraft just right so that the light from the sun itself struck the spacecraft in such a specific way that it could maintain the precision of pointing it needed to continue its mission despite two gammy knees. Love that expression. Thank you, Campbell Duncan, one of the space cadets. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Yes, you. Go to patreon.com/pmsutter to learn how you, yes, you, can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708. Leave a voicemail if you want, or you can join me on the air. You can also catch the YouTube and Twitch live streams. Go to spaceradioshow.com for the links, or you can follow me directly on all social media platforms. My name is at Paul Matt Sutter. And of course, thanks again, Earthlings, for listening. See you next week, and remember, science is for sharing. End of transmission. Larry's got gammy knees. I think Greg's got a gammy knee. Oh, you need a promo?
I've got two gammy knees.
Greg's got two gammy knees.
I need a promo, and your voicemail did not come through. Did that come from Colin Studio?
It's Colin Studio, so you can download it. It's the only one there. So
you do that before you take off.
Yeah, to make sure you got it. And that didn't pipe out to you?
No.
I was hearing it.
You didn't see me. I was scrambling there for about 30 seconds. Hey, Paul.
Did you guys hear the voicemail? I'll ask the Space Kids because I heard it in my my headphones. Oh, I got the hardcover of my book, by the way. Look at that. Look at that beaut.
You are the real deal.
It's a real thing. I hate every word. Oh, we're still live. No. I need a couple years. I need a couple more years between me and the book before I stop hating it. Or when you guys buy it, you can leave some good Amazon reviews.
Yes.
Some, tell me how much you love it. That might help.
So think about a promo. Let's see if I can grab the voicemail.
Okay, they heard the voicemail on the live stream. Oh yeah, it's the end of the recording, Alexandra, but I'm still hanging out. I'll still be your friend. That's the end. So that's the end of what will go on the air. But I still have to record a promo, still hang out with you guys. So yeah, I see there's lots of questions. And the reason I created Space Radio was that I had a huge backlog of questions for the Ask a Spaceman podcast. So I thought, okay, I'll create a venue where I can answer more questions. And I did. And now there's even more questions and I can't keep up with that. So every episode of Space Radio, I can only get through like 10, 20% of the questions. So I am preparing. I can't do it quite yet. And I'll explain why after I'm able to do it. I know that doesn't make any sense. But yes. Ready for a promo? Okay, sorry, Greg's interrupting me. Promo. An opportunity for you guys to ask more questions. Don't worry, it's coming. It's coming. There's so much stuff in the works. Can you format your Spaceman show like you do the COSI science stuff? No, I can't because that's super expensive. So, I mean, seriously, the COSI stuff only makes sense because we put that on TV, on PBS member stations. And it's produced by someone else. Like, I can't up the production value of that. I can't put in the time or money. Am I going to extend my live streams from 30 to 60 minutes? Yes, that is another thing we're working on. We were hoping to do that back in October. We had to push that back for various reasons. We're aiming for January to do longer shows. So, and don't worry. You ready? Pour one out for the great planet hunter in the sky. The Kepler mission is at an end. Join me in eulogy. 2 p.m. Saturday on Space Radio. I'm Paul Sutter, and on WCBE 90.5, we will talk about the legacy and the life of Kepler. Yeah, I need like 20 interns. I need 20 interns, seriously. Where do you get interns? And wait. Where do you get good interns? That's what I need to know. Oh, Larry, so the COSI stuff, that's funny. You say I sound unnatural. That it's my normal thing. So those are unscripted. I rehearse them. I come up with this topic like the night before. And then
Hi, Paul. This is Alex from Allentown, PA. I caught Ask the Spaceman yesterday, and we were talking about strange lights. And ever since I heard of Cherenkov radiation, I just thought it was the coolest thing. And when I saw pictures of it, it made me wonder. I love the blue glow of it, but is that because of the medium that the charged particle is going through? Or would it be a different color in a different medium like glass or air?
It's a good question.
And what about the charged particle? Does that make a difference in the light? And lastly, what would a spectroscopy of that light show? Would it be the medium or something else? Thanks, Paul.
There we go. You got that one, Greg?
Hi, Paul. This is Alex from Allentown, PA.
You playing it again?
I caught Ask the Spaceman yesterday, and we were talking about strange lights. And ever since I heard of Cherenkov radiation, I just thought it was the coolest thing. And when I saw pictures of it, made me wonder. I love the blue glow of it, but is that because of the medium that the charged particle is going through?
I don't.
Or would it be a different color in a different medium like glass or air? And what about the charged particle? Does that make a difference in the light? And lastly, what would a spectroscopy of that light show? Would it be the medium or something else? Thanks, Paul.
There we go. Now you guys have really absorbed that question. So yeah, the COSI Science Now bits, I prep them in the car ride from my house to COSI, and then I go in and I do it, and it's usually 1 or 2 takes and we're done. All right, I gotta go. Thank you, everyone. As always, amazing questions, and I'll see you next week.